Welcome. Let's discuss how we can find the length of arcs in any circle. In the following examples, we want to find the length of the arcs that are highlighted in blue. Within example 1, we are given the length of the radius of this circle, which in this case, it is 2. And we're also given the central angle that creates the arc that we're interested on, which in this case, it's 92 degrees. But don't forget that we know how to find the perimeter of the whole circle. That is 2 pi r. Essentially what we're saying, we want to find out the length of just a small section of the whole perimeter of the circle. How much of the perimeter? Well, if we would have gone a full circle, we would have covered 360 degrees. Out of the 360 degrees, we only want 92 of them. Now we can think of an equation which we can use to find the length of the arc. It will be equivalent to the whole perimeter of the circle. And then we're going to multiply by the section that we're interested on. Where theta, it is the central angle that produces the arc that we're interested on. So now let's find the length of this arc. The perimeter is 2 pi r. R is a value of 2, times the section that we want is 92 degrees out of the 360 that are in a full circle. This expression right here, that is equivalent to 4 pi. And notice that we're multiplying two fractions, so the numerator is going to be 4 pi times 92, which is 368 pi. And the denominator, it is still 360. Now let's find this value using our calculator. So let's open a parenthesis for the numerator, and let's put down 368. And to access the pi button, we're going to press second and exponential. Now let's close the parenthesis and divide it by 360. So we have our result. The length is equivalent of 3.21. Now notice that the length of the radius was given to us in centimeters. Therefore, the length of the arc is also in centimeters. Looking at example 2, we are given that the radius is equivalent of 3 centimeters. And the central angle that creates the arc of interest is of a value of 250 degrees. So we have all the information that is needed to find the length of the arc. That will be equivalent to the whole perimeter, which is 2 pi r, where r is of a value of 3, times the section of the region that we're interested, which is 250 degrees out of 360. If we multiply in the first parenthesis, that will be equivalent to 6 pi, and 6 pi times 250, that's equivalent to 1,500 pi. Let's divide that by 360. Now we can use our graphing calculator to find this value. Let's open a parenthesis for the numerator, and let's place down 1,500 pi. To access pi, we're going to press second and exponent. Let's close the parenthesis, and now let's divide by 360. So we have our result. The length is equivalent to 13.09. But because the radius was given to us in centimeters, then the length of the arc is also in centimeters. So let's summarize. In our first example, if we were to measure the length of this arc, that would have been a total of 3.21 centimeters. And in our second example, if we were to measure the length of this arc, that would have been equivalent to 13.09 centimeters.
Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.